In this video, we are going to conclude our work on straight line graphs. We're going to be focusing on parallel lines and the general equation of a straight line graph, which is y equals mx plus c. First, we're going to revise how to find the gradient of a straight line graph. The gradient is how steep the line is, and we find it by dividing the change in y over the change in x. Sometimes that is referred to as rise over run. Looking at the yellow line, we're going to see how many spaces it's going to go across and up or down. So we go 1 across and 2 up. That means that our change in x is 1 and our change in y is 2. So that is 2 divided by 1, which is going to give us 2. The gradient of the yellow line is therefore 2. Looking at the blue line, we go 1 across and 1 up. So we write that as 1 over 1, which is going to give you 1. So our gradient of the blue line is 1. Looking at the green line, we can see that it's in fact sloping in an opposite direction to the others. It is sloping from right to left. This tells us that it's going to be a negative gradient. But we still have a look how much it's going to go across. So we always, when we are looking at straight line graphs, moving to the positive direction in the x-axis. It's going 3 across and 1 down. So the way to write this is we're going to have a negative 1 in the change in y because it's gone down. It's gone, it has moved in the negative direction on the y-axis. And it's moved a positive 3 on the x-axis, so we've got negative 1 divided by 3. We can't leave our answer like that because that negative refers to the entire fraction, because remember, negative divided by a positive is going to give us a negative, so we write it as negative 1 over 3. The purple line, we are going 3 across and 1 up. So our change in y is 1 and our change in x is 3. So that's 1 over 3, and our gradient of the purple line is a third. The equation of a straight line graph takes the form of y equals mx plus c, where m is the gradient and tells us how steep a line is, and the c tells us where the line crosses the y-axis. So this shows us the equation of a straight line graph where the coefficient, the number in front of the x is 2, and our constant, our c, is positive 5. So the gradient of our line is 2, and the y-intercept of this line is positive 5. That, the sign, the plus sign, belongs to the 5. It tells us that that is a positive 5. In this equation, our coefficient in front of the variable, okay, so x is the variable, 0.5 is the coefficient, it is 0.5, and that is our gradient, that is our m value. Our m value is 0.5, so our gradient is 0.5, and our y-intercept is negative 8. In this one, it looks a little bit different because the equation isn't in the form of y equals mx plus c. However, we can still see that we've got an x and that the x has got a number in front of it. So the number in front of the x is always our gradient. If there's no number in front of the x, it means that the gradient is 1. And in this question, the y-intercept is 3. So what is the y-intercept in this question? In this question, it will still be our c value, our constant. And that means we're looking for the number that's on its own and doesn't have x attached to it. And that would be 25. So 25 is where our graph would cross the y-axis. Our gradient in this question would be negative half, because that is the number, that is the coefficient of x. To find the gradient of this line, we need to rearrange the equation to the form of y equals mx plus c. Currently, we do not have that. So don't be tempted to read the gradient of this as it is and simply look at the value in front of the x. You can only do that if it's in the form of y equals mx plus c. That is a common misconception. So in order to get it to that form, we need to take 9x away from both sides. That is going to give us y equals negative 9x plus 8. And now we can do what we know and just read the number in front of the x, and that is going to give us negative 9 as the gradient of that line, with positive 8 as the y-intercept. Again, in this one, finding the y-intercept in this equation, we would not be able to simply look for the constant or the number on its own, because the equation is not in the form of y equals mx plus c. Rearranging the equation, we would add 7 to both sides. That means that it disappears from the left-hand side because it cancels out, and our resulting equation is y equals 0.5x plus 7. So our y-intercept is 7 and our gradient is 0.5. So here we've got an investigation that we can carry out. If we plotted the graphs that we have been given, we can either use our table of values as suggested in the slide, or we can use our knowledge of gradient and y-intercept to plot them, and then we can see what we notice. So what stays the same and what changes in the graphs, and what stays the same and what changes in the equations. If you would like practice plotting these graphs and doing the investigation yourself, then feel free to pause the video now and do that. Okay, so if you have either plotted them and just come back, or you are waiting for me to discuss this, then let's do that. Looking at the equations of the graphs, we can see that the things that stay the same are the coefficients of x. The number in front of the x is the same. It's all 2. That means that our m value is 2 in every single equation, and that means we have got the same gradient. Okay, what changes is our constant, which is the y-intercept. So we've got the equations plotted on this slide, and we can clearly see that if the m value is the same, we are going to get parallel lines. So we can conclude that parallel lines, which are lines that never meet, even if they carried on forever, have the same gradient, the same m value, but different y-intercepts. This is a key point, and if you need reminding of it, make sure that you make a note of it in your books. So pause the video and make yourself a little note. Okay, so here we have got examples of lines which are parallel to y equals 2x plus 5. So as you can see, all our m values are exactly the same. Okay, so if we were in class, I would ask you to think, pair and share about which lines that appear in here now are in fact not parallel to y equals 2x plus 5. So pause the video and simply think about which ones are not parallel, and then the next slide will show you the answers. Okay, so these are the lines that were not parallel to y equals 2x plus 5. As you can see, the gradients are different. Did you get them right? So this is our exit question. For a get to 5, you need to be able to tell me which of the following lines are parallel to y equals x minus 5. It's a multiple choice. A is highlighted for no specific reason, so don't worry about that. It's simply the way it comes up when you select it. So have a look and email me your answers. Tell me which ones are parallel to y equals x minus 5, and remember that some of them you might have to rearrange. And have a little think of what you learned today. Has this little video helped to clear up some of your misconceptions or misunderstandings? And are you confident that you will be able to read the gradient of a straight line graph from the equation, even if it is not in the form of y equals mx plus c?